The final video I'm going to produce in this lesson really isn't any different than the video 7. So if you understand video 7, all that number 8 is really trying to highlight here is to check for extraneous solutions, but otherwise the solution strategies that I have already highlighted for you and modeled for you are still going to be in effect. So in question 8a, I will run through these. First primary goal is to write is as a single logarithm statement, so we're condensing it to a single natural logarithm statement. So it's natural log of, if you see subtraction, that means we have division that was implied. So we're using our quotient rule. So 6y plus 2 divided by y plus 1 equals the natural log of 2y minus 1. And I could put that argument in parentheses. So to undo a natural logarithm, the inverse of a natural logarithm is to exponentiate both sides to a base e. Exponentiating a natural logarithm is an inverse, so we reduce that. So you got 6y plus 2 all over y plus 1 would have to equal 2y minus 1. And then we start simplifying this equation. This is a rational equation that we did in the previous unit. To get rid of a rational equation, you multiply both sides by least common denominator. In this case, the only denominator is y plus 1. So we got 2y minus 1 times the y plus 1. I think I didn't get the 1 in there, so let me try to rewrite that clear. We have the 2y minus 1. We're taking it times the y plus 1. Okay, so in order to simplify this, we're going to have to make sure that we use our distributive property. So 6y plus 2 has to equal, and then we got a 2y squared. We got a plus 2y, a minus a y, so that's a plus y, and then we got a minus 1. Collecting our like terms, then we have 0 equals, again it's quadratic, so I'm going to get one side equal to 0, so 2y squared. You're going to subtract 6y, so it gives us a negative 5y. And we're going to add, or do the opposite of adding 2, which is subtracting 2, so negative 3. And we've been here and we've seen this equation earlier in the lesson, so we get the same quadratic equation that we had before. 2y and y minus 3 and then plus 1, which meant our solutions were for this, or potential solutions, let me put it that way, is y equals a negative 1/2 or a positive 3. Again, the emphasis is on checking solutions, so make sure you plug those back in and make sure you don't take the log of a negative number. That's really what our concern is. So our two possible solutions were negative 1/2 and a positive 3. So let's try this. If we take a negative 1/2 and put it in for y, what's half of 6? So that's 3. So negative 1/2 of 6 is a negative 3. So negative 3 plus 2 is a negative 1. You cannot take the natural log of a negative 1, so you disregard or discard that solution and don't put it in part of your solution set. Testing the 3. Unlikely that 3 is going to be a problem, but we'll plug it in and make sure. 3 times 6 is 18 plus 2, that's fine. 3 plus 1 is fine. And 3 times 2 is 6 minus 1, so that is fine. So in the end, our only solution for this problem is 3. Final one in our lesson, write it as a single log. This time they get a little bit more deceptive on this. How do we write this as a single log? So this is a common log, log of base 10 equals, now I want to write this too, I really like to write it as a log statement and a log of base 10. So what is it that I can raise 10 to get 2? So I want to rewrite this log of base 10 of some number is 2. I want to rewrite 2 as a log statement. And since the exponent is 2, that means we're going to take the log, or common log, of, and 10 to the squared is 100. So we had to take the log of 100 to get 2. So I'm going to replace that as 100 plus the log of x minus 2. Now it may not seem completely apparent why I did that at first, but what I want to be able to do is write this side on the right as a single log statement. I don't want a log statement with a constant if I can possibly avoid it. So that's the purpose of doing that. So now, log of base 10 of x minus 12 equals common log. I'm just putting in the base 10 as an emphasis more than a necessity. 100 times x minus 2. Now to get rid of a log base 10, I'm going to exponentiate to a base 10. Before we were using e because it was a natural log, and e is the inverse of a natural logarithm, and an exponential base 10 is the inverse of a log base 10. So what we get is an x minus 12 on the left side, On the right side, the inverses of an exponential base 10 log base 10 reduced, and you have 100 times x minus 2. This looks like it'll be a linear equation, so we can solve this linear equation. We've got x minus 12 equals, by distributing 100x minus 200. Then we're going to isolate x's on one side since it's linear, so I'm going to move the x over here. 99x, move the 200 over here, so that's adding 200 makes it 188. We have to take and divide both sides by 99. So it looks like our apparent solution should be 188 divided by 99. Now, in order to check it, I think it's easier for me to get a decimal approximation for that, and I can run that through. I do not want to update it at this point. So I'm going to take 188, I'm going to divide it by 99, and that is about 1.9. So it's approximately a 1.9. Now, is this going to be okay to put back into our original equation? So I'm going to go check that solution. So if I have a number that's approximately 1.9, is it going to create any problems with the logarithms? Well, immediately I can see that I'm supposed to take a 1.9 minus a 12. That's going to give us a negative argument, so that this logarithm would be undefined. So the only possible solution that we found is not acceptable. So on this one, our simple answer is this is not a solution. Therefore, we have an empty set or a solution set, or you can say there's a null set. Either way. Bottom line is, when you solve your log equations, try to rewrite it as a single log statement on each side of the equation, then exponentiate to the appropriate power. Then what you can do is run through you probably are going to get either quadratic or linear equations, solve it as you normally would. Finally, don't forget to check your solutions. That's the point of question number 8. You have to check for these extraneous solutions, otherwise you may be putting in false answers. So that's it. That's all we have in this lesson.